Welcome to this video. Looks like we're going to be starting exponential functions. We're going to do some practice problems on exponential functions, how they look, and maybe the general form as well. All right, this section is only 3 problems, so I might do 2 sections in this video, 2 sections from this book that I've been working through in this video series. Okay, let's begin. So, to maybe start off, let me introduce what an exponential function kind of looks like. If we have some power a to the x, this is our f of x, let's say. F of x is a to the x, where a is the base of the exponent. So notice the inputs, the independent variable, is the power. So you can imagine when x is 0, what's something to the 0 power when a is not 0? That is 1. Okay, so there's be a point there. And then as x gets bigger, this is going to grow really fast because imagine a squared, a cubed, a to the 4th power, a to the 5th power. You can imagine it's going to grow really fast if a is positive. So it'll look something like this. And then as x gets more negative, if assuming again a is positive, it's going to, and greater than 1, it's going to look like this. So there's an asymptote for this basic form, or sometimes books call it the parent function. There's an asymptote, horizontal asymptote at y equals 0. It never touches 0 because it approaches 0 but never touches 0 as x gets smaller. And then over here, it keeps growing infinitely and it grows really quick. So this is the basic form of exponential function. And of course, you can apply transformations and all that, which I'm not going to go over here. Okay, let's begin now. So maybe actually before that, one more thing. I think earlier I said this is when a is positive and greater than 1. Okay, and this we typically call is like exponential growth. Decay, exponential decay, is just a reflected version. It looks something like this. Okay, so either your exponent is getting more negative, or a is less than 1 but greater than 0. Either works. Okay, now let's begin. During a decade of continuous droughts, the water level of the lake has decreased 10% each year. Which of the following graphs can model the water level of the lake as a function of time? Okay, so imagine something's decreasing 10% each year. So let's talk about it in terms of money, that people can easily imagine things when it's money. Okay, so let's say you have $100. You lose 10% of it, so you would lose $10. So you have $90 now. Okay, if you lose 10% of that, 10% of 90, then you'll lose $9. So you'll have 90 minus 9, which is $81. And then if you lose 10% of that, you'll lose $8.1, and then so on and so forth. Okay, so you can see it first decreased by 10, and then by 9, and then by 8.1. So it's not a linear decrease, which we expected from this section. So we can already eliminate b. That's a linear function, and similarly here, this is linear. Okay, now it's decreasing by 10% each year. This looks like it's increasing, so we can eliminate that right away. Same logic for this one, even though it's also linear. It's increasing. It's saying it's decreasing as a function of time. So the best answer is A. You don't really even need to look at the numbers and all that, which they don't really give you. And that was the point of this problem, probably. Okay, number 2, lots of words. You know I don't like reading these if you see my other videos, so let's skim it. Graphical exponential curve of 2 different cars, function of time. At t is 0, A is this guy, B is that guy. Time t is 6. Okay, so it's just saying the 2 points. 3 points, 1, 2, 3. Okay, and these are common to both A and B, it looks like. Based on the graphs above, which of the following must be true? At time t equals 0, the price of model A was 25% more than the price of model B. Is at time is 0, so right over here, or even gives it in the description, right? T equals 0. What is price? Well, 25% more than the price of model B. What's 25% of this? What's a fourth of this? That's $6,000. That seems to be true. That's $6,000 more. All right, so that's true. Let's keep it. At t equals 0, the price of model B was 20% less than the price of model A. So it's asking, the only difference between choice 1 and choice 2 is this is with respect to price of model B. Now it's asking with respect to the price of model A. It's asking kind of the other way around. Okay, so what is 20% of 30,000? If you quickly do it in your head, that's 6,000, right? So is this 6,000 less? It is. So this is true as well. Okay? From time t equals 0 to t equals 6, the average rate of decrease in the value of model A was 1.5 times the average rate of decrease in the value of model B. What is average rate of decrease? That's probably the point, the critical point in this choice. Average rate of change is just if it's changing linearly across time, what is the slope of that line? That's all average rate of change is. A constant rate of change. Versus here, it's not changing at a constant rate. It's exponentially decreasing. Versus if it's constant, it's linear. Okay, so it's asking what is the slope of the line if we just draw straight lines from those 2 points. So let's do that. So for A, it's 30,000 minus 12,000. So 30K minus 12K over how many years? That is 6 years, right? So that is, by the way, it should be a negative slope. So let me change the signs a little bit like that. Okay, so this is what? Minus 18,000 over 6 years. So this is minus 3,000. Okay, now for the other one, for model B, is 24 to 12. So 12, so minus 24K plus 12K over same amount of time, 6 years. That's minus 12K over 6 years, which is minus 6,000, right? Sorry, minus 2,000. I was thinking the 6, but minus 2,000. So is the average rate of decrease, this was A, by the way, this is B. Is this 1.5 times this? It looks like it is, right? Because half of this is minus 1,000, this is minus 1,000 less, right? Or more, whatever the terminology is. So that seems to be true. And so all 3 are true. Okay? Last one in this section, if f of x is this guy, and g of x is this guy, what is the value of g of 2 minus f of 2? Okay? Just plug this into your calculator if you're allowed a calculator here. This is 14,000 times 0.85 squared minus 12,000 times 0.9 squared. Plug this in your calculator, you should get 395. That's the answer. Okay, I'm assuming this one you're allowed a calculator. If not, good luck doing it by hand. Shouldn't be that hard, but okay. Let's do this section as well. Exponential growth and decay, as I was saying earlier. If A is positive and greater than 1, assuming your exponent is positive, then it's growth. If A is greater than 0 but less than 1, it's decay. Okay? Number of rabbits in a certain population doubles every 40 days. If the population starts with 12 rabbits, which the following gives the total number of rabbits in the population after t days, okay? So there is a general formula for exponential growth and decay, okay? So you could memorize it. It's something like, what was the initial value? You can put, oh, it's cut off. You can put whatever value, but usually in, I use exponential, the e to the kt, something like that. Okay? And then sometimes you could change the base of the exponent, because like here, it's doubling, so you can change this e to a 2 or something like that. Okay? If you don't know this formula, you should know it, but there's a different way to think about it. So this is saying it starts off with 12 rabbits. So when t is 0, you have 12 rabbits. Which one does not give that? When t is 0, you have 0, cross that out. When t is 0, you're dividing by 0. You can't do that. Here, same thing. You're dividing by 0. You can't do that. So answer is D right away. Okay? As simple as that. I didn't even need to know the general formula. And there's one for, as I said, for population growth, if it doubles. It's like y is y0 times 2 to the t over d, where d is the days to double, t is the time. Okay? So you kind of did that as well, because following this formula, d is 40. And then that's exactly it. But as I said, if you don't know this formula, just use some, I don't want to say common sense, but just think it through. When t is 0, no time has passed, you have the initial 12 rabbits. Which formula gives that? Only d does. Okay? So I would rather actually think of it like this. Okay, next. Population P of a town is 80,000 this year. If the population of the town decreases at a rate of 4% each year, which of the following expressions gives the population P after t years? Okay, so let's use similar tactic to what we did there. Let's see if we can eliminate anything. Population of a town is 80,000 this year, so after t years, so again, this is when t is 0. Okay, can we eliminate anything? Looks like this one, when t is 0, you have 0 population? No. When t is 0, you have 80,000, that's fine. These are fine as well. So we eliminated only one of them. Okay, so if the population of the town decreases at a rate of 4% each year. Okay, so after 1 year, it decreases 4%. So how much do you have left? You would have, so after 1 year, you would have 96% left. Okay, so which one gives us that? 96% of 80k, so when t is 1, after 1 year t is 1, we multiply this 80k by 0.96, 96%. This seems to be right. This one clearly doesn't seem to be right, cross that out. This one seems okay for t is 1, right? Okay, but when t is 2, after 2 years, we would have to do 0.96 squared of this, of meaning multiply. Because we want 4% decrease after 1 year, so multiply it by 0.96. And then after another year, another 4%, so multiply by another 0.96, so 0.96 squared. So it looks like it is B. Okay? Again, I didn't need to know the general model. See, this is for doubling, that's fine. This is percent growth. There's probably a formula, but I don't remember, honestly. And I'm looking at my answer key now. Looks like they want you to memorize this formula, 1 plus r to the t, something like that. If you see my videos before, I don't recommend memorizing a bunch of things. So just think it through, like something like this. Honestly, that's what I would do on the exam. Didn't take that long. Obviously, if you know this formula, it would be a little quicker probably, but it didn't take me that long to think through or eliminate choices. As far as I can tell, it worked so far, right? Okay, a house bought 10 years ago for 150k was sold for 240k this year. Which of the following equations can be used to solve the annual growth rate R of the value of the house? Okay, so again, I don't know the formula. It's probably this formula over here, some variation of it. Again, I don't know it though, so let's use the technique that I've been doing so far. Okay, so when following can be used to solve the annual growth rate R of the value of the house. Okay, so let me see. This is a little different. Now, if I don't use that directly, let me think. Well, it's going to be an exponential because annual growth rate. And if you know the housing market, it doesn't work linearly, really. At least not to my knowledge. I've never seen it before. It works as in like percent growth decrease, which is exponential. Okay, so we can already eliminate probably A and B because these are linear models over here. Okay, now which one is it over here? Well, if I have an annual growth rate of, let's say, even just 1%, well, let's make it extreme, 100%. Okay, so if it's 100%, that means it should be doubling, right? Would that work for choice D? 100% is 1. 1 to the 10th power, you're just multiplying 150k by 1. There's no growth. Eliminate that. Choice C. That's clearly the answer. Again, I didn't need to know this formula again. I just knew, just from, if you know a little bit about the housing market, I guess that's the prerequisite here, but you don't really need to. It tells you that it's annual growth rate. So that should already signal exponential growth decay. You can eliminate choice A and B. These are linear models. And then if we take an extreme value of 100% growth, meaning it doubles, this model clearly doesn't work because 100% it means R equals 1. There's no growing at all. All right? Okay. Number 4. A certain radioactive substance has a half-life of 12 days. That means every 12 days, okay, that's what half-life is. If there are 128 mg of the substance today, how many mg will be left after 48 days? Okay, so again, if you don't know the formula, just do this a little manually. Because after 48 days, how many halves occur? That should be 4 halves, right? 12 times 4 is 48. Okay, so 128. So you can divide by 2, because that's what half-life is halving. And it occurred 4 times, so 2 to the 4th power. Or you could do 128 divided by 2, and then take that result, divide by 2, take that result, divide by 2, and take that result, divide by 2. Same thing. But this is obviously nicer to just simply calculate 128 over 16, right? And what is that value? That is 8. Okay, again, no formula was needed. 5 and 6 refer to this. Those are the compound interest, everyone's favorite, because again, people love when there's examples of money because it's kind of easier to understand. Evelyn deposits $3,000 into her bank account, which earns 4% interest compounded annually. She used the expression this guy to find the value of the account after 2 years. What is the value of X in the expression? So this is the growth rate. You want to earn 4% annually. So it should be 1.04. If it's just 1, you're not growing anything, right? 3,000 times 1 to who cares what power? It's just 1. You want it to grow, so you need it to be greater than 1. So 4% more, that's 1.04. Okay? Evelyn deposits the same amount into an account that earns 5% interest compounded annually. How much more money than her original deposit in the account with 4% interest rate compounded annually would she have earned in 10 years? Okay, so for the 4% account, it's 3,000 times 1.04. How many years? 10 years. In the 5% account, it's 3,000 times 1.05 to the 10th power. Plug these two into your calculator. The first one you get 4440.73. The next one you get 4886.68. Subtract the two. Clearly, this 5% would make more, as we expected. That's $446 more about. Okay, so you can see the effect of compound interest just by this. This is why people like to see examples when it's dealing with money, because this is kind of easy to visualize. You most likely handle money in everyday life, whether it's you or your parents or whatever. So you can see that if you start early with a decent interest rate, and 1% is actually a big difference in the real world for interest rate. So you can just see that if you have a 1% difference after 10 years, you would make almost $450 more. I would want that $450. So again, this just goes to show that it's kind of easier to understand examples if these kind of everyday life scenarios. But anyway, okay, so that's it for this video. I did 2 sections that took longer than I expected, but that's okay. Please like and subscribe if you found this helpful. But more of the story is, to recap, For this exponential growth decay, it's nice to know the equations of the models, but honestly, I don't remember them off the top of my head. You can, if it's multiple choice, which most of the SAT exam is, just use some, again, I don't want to say common sense, but use some knowledge to eliminate the choices that don't make sense at all, as I did in most of these problems, okay? And hopefully I see you in the next video. Bye.